There were plenty of WYSIWYG editors back in the day, from the often bundled Atari works to the DTP behemoth that was Calamus. But for serious authors of serious content, there was a problem. Try creating a 200-page thesis or book in either of them and see what happens. I mean, go on, try it. I'll wait. Or don't, because it really won't work and you don't want to waste your time. For academics who have to follow strict guidelines for publication, to say mathematicians who need to be able to write complex equations in their documents, even modern day word processors don't really cut the mustard. So what are we going to do? Well, back in the 90s, as it is today, the answer is usually to use an application called Latex. Some of you will instantly start screaming that I'm pronouncing it wrong, but give me a minute and we'll get to that. Now, the basis of Latex is TeX. TeX is a typesetting system written by a Turing Prize-winning certified genius called Donald Knuth. Now, Knuth was so upset at the quality of digital typesetting for the 4th volume in his magnum opus, The Art of Computer Programming, that he took a multi-year break from writing it to create TeX so that he could get the job done properly. The first chapter of Knuth's book on TeX is called The Name of the Game, where he is very clear that it is pronounced TeX. Very clear. So TeX it is. Now, Latex is a large collection of TeX macros that take care of the layout and styling of documents. It removes the need to concentrate on the underlying typography and allows you to concentrate on the content. Latex was written by Leslie Lamport, another certified genius and Turing Prize winner. And in Lamport's book on Latex, he has a section cheekily named The Game of the Name, where he very clearly states that he's not really bothered about the pronunciation. It can be pronounced LaTeX, Latex, or even Latex. The relationship between Latex and TeX sort of echoes the classic way that manuscripts were turned into books. The author produced the manuscript. This was passed to the book designer, who decided on the layout, things like borders, gutters, where footnotes are displayed, chapter heading styles, all sorts of gubbins. Then that was passed to the typesetter, who put the sorts together that formed the print. And in our case, we are the authors, Latex is the book designer, and TeX is the typesetter. So how do we get TeX and Latex for our Atari ST? That's not quite as simple as it might sound. There are components and subcomponents. TeX is comprised of the TeX executable itself and the metafont application that creates bitmap fonts at various resolutions from font definition files. Latex, while a set of macros, is also accompanied by helper modules like bibtex that allows an author to build up a database of references and citations. Now, you can go out and you can actually find all of these components separately, install them and configure them. But the easiest approach is to find a Latex distribution that bundles all of them in one installable and pre-configured system. Now, I knew of 2 distributions that were around back in the day, ST-TeX and Multitech. So I looked around online and I couldn't find them anywhere. Luckily, I found a copy for sale on eBay and partnered with the cash for it. And here it is in all of its 8-disc glory. Installing it is as easy as inserting disk 1 and running install.prg. And after that, it's a case of inserting each disk in turn and clicking the install button once again. Now, the whole install took about 25 minutes, so obviously I'm not going to show you all of that. Post-install, on the drive I selected to install to, which is the D drive, we have TeX and Metafont as folders. As I mentioned, Metafont is an application for converting font metadata into bitmap fonts. It's kind of similar to VDI under Gem, I guess. But let's have a quick look at the size of the installation. So Metafont weighs in at around 2.5 meg. And the TeX installation itself comes in at about 7.5. So at a combined size of 10 megabyte, from the perspective of an Atari ST back in the day, that's one heck of a hefty application. I think my first hard drive I ever had for an ST was 15 megabytes in total. Inside the TeX folder, we see subfolders for lots of things. bibtex, the tool for managing bibliographic data, folders for fonts, printers, and other devices. Init.txt is an application that compiles TeX files into .format files. So when Latex is loaded, instead of loading latex.txt, which would take over 60 seconds, it loaded the binary version, the .fmt, which takes around 10 seconds. Now, on a modern day system, you wouldn't need to do that, but back then, that was a good improvement. I'm not going to cover all the folders in here because I don't even know what most of them are. So the styles folder contains definitions of styles, like we've got article, book, so on, and at different font sizes. And finally, most importantly in here, there's tsh.prg or TeXshell, which is the tool we're going to spend most of our time in. So let's spin that up. We're on a non-multitasking ST here, so you can only run one app at a time plus some accessories. Because LaTeX requires you to run multiple apps, editors to create content, tech to run LaTeX and produce our document, and a DVI previewer to actually show the content. And that's a lot of swapping of apps. So running those tools via a shell like TextShell makes the workflow much easier. You may notice that the UI is very German, and unfortunately for me, I don't speak the language. However, it is easy to pick up what to do with a little help from Google Translate, and there are only a few menu items that we need to use day to day, and they all have keyboard shortcuts that make sense in English, like E for edit, for example. So let's select our main file, this one here called test.tech. In this menu we have options to edit, to run tech, and if successful, to launch the document preview. We can run the DVI previewer separately. Via this option, we can also send it to the printer. And we can do things like run bibtext and make index from this menu. Although, to be honest, they're things that really I only ever used to do at the very end of the process. So let's start with edit, which is the shortcut E, and it opens the document up in Micro Emacs. This is a console-based editor. It's well featured. It operates as a bit like a cut-down version of Emacs, but it wasn't based on a single line, I don't think, of the Emacs code. It uses some fairly common key combinations. For example, to save it, it's Ctrl+XS, and to quit the editor, as we're about to do now, it's Ctrl+XC. So we're back in the shell, and we're going to press T to run tech. Now, it's worth noting in the console output here that we're using LaTeX 2.09. That's not the current variant. The current variant in the modern day is LaTeX 2e. This distribution came out about a year before LaTeX 2e, so I don't know if there is a version of that out there somewhere to find. But if you're familiar with modern LaTeX, you just might find a few of the commands and formatting things a little different. If everything goes to plan and tech completes successfully, the preview should pop up and here's our Hello World document. Hopefully what you can see here is that we have a pretty quick iterative workflow. E to edit, T to run text, escape to get back into the shell, and off we go around the loop again. So let's get back to the editor. Now in our document at the top we have this line, format LaTeX. So starting with a percent makes this a comment line, but the format LaTeX part is an instruction to multitext to tell it to load the LaTeX style into the document. LaTeX main documentation was in this book. In many places that book refers to a thing called the local guide. And the local guide was a document describing the low-level details of your system implementation. And things like the percentage format statement here are exactly the type of things that the local guide contained. The next thing we have in the file is a document style command. As a parameter, it takes the type of document to produce. And the document style can be article, report, letter, book. I think they're the only four that I have on my system. These affect the page layout, so margins and things like that, which we're going to cover later. So the body of the document is contained between a pair of begin document, end document commands. Begin X, end X is a frequent pattern that we're going to see throughout this video. So I'm going to delete the content and start looking at how a new document hangs together. So we're going to start by adding a little metadata. That's known as the front matter. I'll set the title, the author, and the date to today. Now LaTeX, /LaTeX and /today are commands that don't take parameters. /begin, /end, and /document style are commands that do take parameters. So while we've added this front matter, it's not actually visible in the document yet. To make it visible, we need to add the make title command into the document. So let's put it there. We'll save that, run it, and if we have no errors, we should see the document. Okay, that's good stuff. Let's quit that and go back to the editor. Now, HTML has headers like H1, H2, and LaTeX, being paper orientated, has sections, subsections, and sub-subsections. So let's create one called introduction. Now, excuse me while I type away to get some content to play with, but you should notice how paragraphs are created by inserting an empty line between two sentences. Let's get into the preview. And as the text mentions, you can see that LaTeX is doing its job as a book designer here, from the layout of the front matter, the style of section titles, to the fact that the first paragraph in any section is unindented while the rest are not. This is all book design. And more importantly, all of that is taken care of, so you, just like I said before, you concentrate on the content. So LaTeX supports bold, emphasis or italic, and underline. The early versions of LaTeX used text toggle on, toggle off approach, which is what you're seeing here. In later LaTeX implementations like LaTeX 2e, these became macros like /sections. Though, since underline comes from the maths package, it is a command. It is not consistent. It got much better in 2e. You might also notice that after the LaTeX macro, I added /space. That's because macros like LaTeX and tech actually act like letters rather than words, and so you have to specify a space after. Or in some cases like this, perhaps not, as you want the full stop right after the tech symbol. I'll fix up those broken ones above later. Lists are created as begin-end pairs. You use the class of either itemized for bullets or enumerate for numbered lists. In both cases, items are just added by starting a line with /item. Let's save and run that. All right, we got an error. Error messages in LaTeX at this stage, not that easy to understand, although like compiler errors, you do eventually get used to working out what they're doing. It says undefined control sequence /item. Notice it has a capital I and LaTeX is case sensitive. So we'll fix that, save the file and run tech. There you go. We have some basic formatting and a pair of lists. Now I've said before, LaTeX is about books and scholarly articles. As such, numbered and referenced sections are a vital part of the mix. So here we're creating a subsection, and subsections are numbered and styled according to the document class. And as with sections, the first paragraph is indented, the rest are. Let's look at that. Too many S's. Actually, yeah. So what that error message is saying that I'm using an open parenthesis instead of an open curly brace. So again, not the best error message in the world. But once we fix that, we get the expected content. Now I want to have a quick look at tables because, tabular data is very important in scientific stuff. There are two types of entity at play here. The inner command is tabular, and that's what you might think of as the visible table. The parameters of the tabular command, we specify the table columns, and the pipe characters show where we want vertical lines. So here I'm saying I want a vertical line outside of the table and in between each column. So each content line is separated by ampersands between the columns, or you put an H-line command in there if we want a horizontal line to appear. It's an odd syntax to modern eyes, but capable of displaying really complex data. The outer table command that encircles the tabular is a non-display element effectively, but it kind of shows the power of LaTeX. The caption will be rendered by LaTeX using the styling associated with the doc class, but LaTeX will also float the table automatically to another page if it can't be shown wholly in line. Adding a caption to a table also allows you to insert a list of tables in your front matter. And now we kind of have 2 pages. So I'm going to hit enter to go to page 2, and here's our table, caption and all. Now, tables are fine, but in a large document like a book, it's often necessary to refer to them from other pages, or possibly different chapters. Particularly when LaTeX might float your table away from the content that surrounds it to another page, you want to be able to say, see table foo on page Y. And you sometimes need to refer to sections, lists, equations, and all sorts of stuff. So to reference an item in a document in LaTeX, first you need to create a label to refer to. So let's add a label to the section for tables and name it sec::tables. We'll also add a label to our table, like so. And here the prefix is tab::label name. Now these are not random 3-letter strings at the start. There are many things you can refer to. You can refer to a chapter, a section, a subsection, a figure, a table, an equation, a list, an item in an enumerated item list, an algorithm, or an appendix subsection. Right, so now we've created some labels. How do we actually use them? And it's as easy as this. We enter /ref open parameters sec::tables, and that will be replaced with the section number that label was defined in. And then here we have a page ref sec tables, and that will be replaced by the page number of the section, of the link rather, that is referring to the table section. /page ref sec tables will be replaced by the page number of that section. So I've added another reference for our table. Let's run tech and see what we get. Right, back in the editor, I've pre-populated a new section on formula. This shows the support for mathematical symbols, such as inline equations and more complex expressions. While we're still in the document viewer, I want to show you one thing. What I'm going to do here is I'm going to set the zoom mode to 2. It's not particularly readable, but let's us see that this is an article. And in an article like this, the document is formatted to print on A4 with even managers and gutters on all pages. So it's not designed for binding, but perhaps for stapling. Now what I'm going to do is I'm going to go back into the editor and I'm going to convert our document into a book, and I'm going to see what happens. And what I'm going to do is add a chapter title. And the reason I'm doing that for the book is if you don't have chapters, then the sections will start numbering from 0, which looks a bit odd. The other thing I'm going to do is add a table of contents. I'll place it after the title and before chapter 1. Now I could also add a list of tables, list of equations, list of figures, all kinds of stuff. So let's generate everything and see what our book designer LaTeX has made of this book representation. So looking at our zoomed out document, the first thing that LaTeX has done is move our title page into a completely separate page. Now here is our table of contents with our chapters, sections and subsections. Now, if you look at this document, you'll see that the guttering is different. There is a broader gutter on one side of the page to the other. If we swap from this page to the next page, we'll see that the gutter is on the other side. So obviously these are on two sides of a page. So that means that the wide gutter is always on the side where it's going to get glued. And when you glue a book, obviously you use up quite a bit of space. So this means that the text isn't in the fold, so to speak. That's kind of some of the differences between an article and a book. When you're working on larger documents, on an ST back then, it was sensible not to put everything into a single file, but to separate it into different ones. This is the main file from my BSc dissertation from 1992. 1992. So let's have a quick look at this. The batch mode command skips outputting error messages for missing files. And that's because there's actually quite a few missing C files and stuff in this current version of this dissertation. But what you can see is that this file mostly exists to include other files that form the content. Now this had two advantages. The files were not so large, so they could fit into memory on a 512K ST. And then these includes could be commented out. So then when you run LaTeX on the main file, it would only format and display the subfile you were working on. So another new thing actually in this document is this /appendix command. That tells LaTeX that from here on in, sections and subsections are numbered not from whatever the last section was, but are now counted from Appendix 1, Appendix 2, Appendix 3. So processing this file on an Atari ST took 2 minutes and 30 seconds, and that's for 90 pages. The original, with code listings, weighed in at 200 pages. So the trick of commenting out most of your includes is a vital one, to be honest. I mentioned earlier that LaTeX was an old system, but one still in use. And you can install LaTeX locally on your Mac, Windows, or Linux machine. And there are distributions like MikTeX, that's the one I use on Mac OS. And here you can see it running inside of VS Code with a live PDF preview. Online, there's a site called Overleaf. Here you can collaboratively edit LaTeX documents and even submit them to journals for peer review before publishing. Here I'm editing the full-ish version of my dissertation, which includes source code, although it's still missing a couple. And this weighs in at 194 pages. For comparison, this online version takes around about 10 to 20 seconds to build that document. So there you go, LaTeX. A skill I picked up in 1992 that's still relative in 2024.